Okay, if you feel like the AI news cycle is just moving at, well, an impossible speed right now, you're definitely not alone. What we're looking at today, October 1st, 2025, is really just a snapshot, isn't it?
It really is. It feels like hyperdrive sometimes. And our job today really is to sift through all that noise, pull out the most important bits you need to know. We're seeing some huge moves, especially around productization.
Right, like OpenAI going social, Anthropic focusing on efficiency.
Exactly. And then there's the big money bets on things like AI for science, plus Jipu making waves in open weights. Lots to cover.
Okay, let's dive in. The thing grabbing headlines has got to be OpenAI's Sora 2 and this whole push into video. The speed alone is kind of mind-blowing.
It really is. I mean, wasn't the first Sora announcement only about, what, a year and a half ago?
Something like that. And the public website, Sora.com, maybe 10 months?
Yeah, the iteration speed is just incredible. That's takeaway number one. And number two is the quality jump. It looks seriously improved.
Well, yeah, the early stuff. Remember how it struggled with, like, basic physics, objects just vanishing or moving weirdly?
Yeah.
How's Sora 2 doing on those physical world issues?
They seem to have made real progress there. The demos we've seen show really complex stuff. Gymnastics, figure skating, looking much more fluid, more believable.
Okay, but how?
Yeah.
Is there, like, a physics engine inside it now?
See, that's the interesting part. The sources say it uses implicit models. So no, not an explicit world model. It hasn't, learned Newton's laws directly.
Implicit models.
Oh, right.
Okay, so what does that mean in practice if it doesn't know the rules?
It means it's learned the behavior of physics by watching just tons and tons of data. Videos, obviously, but also, interestingly, things like video game environments and even browser output.
Huh. So it's more like a super simulator than a physicist.
Exactly. It simulates what should happen based on patterns rather than calculating from first principles.
Gotcha. The tech is one thing, but the way they're rolling it out,
Yeah.
it's aggressive. It's not just a tool, it's a whole social network.
That's the really big shift, isn't it? They've productized Sora 2 into this new iOS app and website. It's invite only for now, US and Canada, I think.
Yeah.
But yeah, full social features, profiles, followers, even DMs. And the core thing seems to be these cameos.
Right, where you upload video of yourself
Right.
for likeness.
Exactly. With consent controls,
Yeah.
they say. But it lets you put yourself or others who consent into generated videos.
And speaking of likeness, there was that one detail, kind of buried, about Sam Altman himself. That felt significant.
Oh, yeah, that definitely stood out. His likeness is apparently available for anyone to use right from the start.
Wow.
So, yeah, day one, you're going to see deep fakes of the CEO popping up in people's feeds. That's quite a statement.
A bold move. Shows confidence in their safety stuff, I guess, though they did mention putting in some kind of anti-doom scrolling timeout feature.
Which is maybe needed. But yeah, it immediately throws up huge questions about identity, consent, deep fakes in a social context. They're pushing that boundary hard.
So it's moving beyond just making cool videos for filmmakers into something much more personal, more about communication. Reception seems mixed, as you'd expect.
Yeah, some people are wowed by the realism, the character consistency feature they talked about. Others still see artifacts, weird glitches, and point to competitors like Google's VO3.
But the anime generation, that seems to be getting crazy.
Oh, definitely. The sources mention broadcast quality anime. That capability alone seems to have taken a massive leap.
Okay, so while OpenAI is busy building this social video world, the LLM race is just continuing at full throttle, especially around coding and efficiency.
Absolutely. And Anthropic just dropped Claude Sonnet 4.5. Their angle seems to be smarter, more capable, but crucially not more expensive.
Right, same price as Sonnet 4, but better performance.
Exactly. Higher intelligence, same cost, and better token efficiency, too, even in its thinking mode, which usually burns more tokens.
And how's it stacking up? Evols.
Independent evils seem to put it, clearly behind the absolute top tier, like GPT-5 High, but ahead of things like Gemini 2.5 Pro.
Yeah.
The big gains seem to be in agentic stuff, using tools and alignment behaviors.
Alignment. Okay, there was that great little nugget from user reports about its personality, or lack thereof.
Yes. My favorite bit, users are saying it's less sycophantic.
Less sycophantic.
Yeah, the phrase going around is literally that it doesn't kiss ass anymore.
I love that.
Yeah.
We worry so much about AI lying, but here's one getting points for being willing to say, actually, that idea is flawed.
It's a really interesting angle on safety, isn't it? Leaning into honesty and critical feedback rather than just being agreeable to avoid offense. Users also report it handles context better, state management, making complex agent workflows more reliable.
Because it's not afraid to push back a bit.
Seems that way. And they're really doubling down on the coding side to leverage this.
What they ship there?
Claude Code V2 plus updates to their VS Code extension, tools for memory and context editing. They're building out a whole environment for agentic coding, clearly aiming to compete hard in that developer space.
Okay, so Anthropic is pushing proprietary coding agents. That sets the stage nicely for the open weight side of things with Zipu.
Right, Zipu GLM 4.6. This was a big release for the open source community. MIT license, which is great, and a massive 200,000 token context window.
Wow, 200K. And the focus? Similar to Claude.
Pretty similar targets, yeah. Better coding, better reasoning, better tool use, agent task success, making it a more capable all-around model.
But open source often struggles with efficiency compared to the big proprietary models. How does GLM 4.6 do there?
That's actually one of its strong points. The claim is it hits these performance levels using about 15% fewer tokens per task, or per trajectory, compared to the previous version, 4.5.
So it's powerful and efficient. That's key for open source.
Absolutely. Benchmarks are putting it close to Claude Sonnet 4 on coding tasks and ahead of other Chinese models. And crucially, it's out there now, available on platforms like OpenRouter, so developers can start using this really capable, long context, efficient model straight away.
Okay, so the LLM battlefield is fierce. Features, efficiency, open versus closed. Now, let's switch gears slightly and follow the money. Where are the big VCs placing their bets for the next big thing? Periodic Labs seems important here.
Yeah, this feels like a really significant signal. Periodic Labs, run by folks with serious cred, alumni from ChatGPT and Google's GenoMA project, just landed a huge founding round, $300 million.
$300 million. For a founding round, what on earth are they planning to build?
Get this. AI scientists paired with autonomous labs. That's the mission.
AI scientists. Autonomous labs. Okay, unpack that.
They're targeting experiment-driven science, specifically things like discovering new materials, superconductors, semiconductors are mentioned. It's not just about running simulations based on existing data.
Right.
It's about having the AI design experiments, run them in automated physical labs, analyze the results, and then iterate, creating new data, doing verifiable science.
That sounds fundamentally different from how most AI is trained today, just reading the internet. What's the core idea driving that massive investment?
I think the core thesis, the really profound bet here, is that internet text is basically a finite resource. We've kind of squeezed most of the juice out of Wikipedia and books and papers. They believe real breakthroughs, especially in hard sciences, now require generating completely novel, high-quality experimental data. And you need a closed loop where the AI learns directly from experiments it runs itself, moving beyond just reading static text to actively doing science.
Automated knowledge generation. That's ambitious and requires, well, $300 million apparently for the AI and the physical robots and labs.
Exactly. It's a huge capital investment. Which actually leads us nicely into our last segment. The underlying tech that makes all this possible, or at least cheaper, training efficiency.
Right, because none of this happens if training these monster models stays astronomically expensive. It all rests on making compute faster and cheaper.
Precisely. It's the bedrock. If model training costs don't come down, the pace slows dramatically. So let's start with NVIDIA's NVFP4.
FP4. So that's 4-bit precision. We've been hearing about lower precision for a while. What's the breakthrough here?
The big deal is getting 4-bit pre-training to work without losing performance compared to the current 8-bit standard. They showed they could train a pretty big model, 12 billion parameters on 10 trillion tokens, using FP4 and match the results of FP8.
Okay, same results, but using half the bits. What does that translate to in savings?
The gains are huge. They're talking something like 6.8 times the efficiency and roughly 50% lower memory usage during training. This directly attacks the cost of building those giant frontier models needed for things like, well, Periodic Labs AI scientists.
Makes sense. Drive down the cost of the foundational model. But cost isn't everything. You also need to optimize the whole training process itself, right?
Totally. It's not just about raw FLOPS per dollar. Which brings us to this work from Apple researchers on compute optimal QAT.
QAT, quantization-aware training.
Yeah. Basically, training the model knowing it's going to be quantized or shrunk down later. The problem is it's often treated as an afterthought, something you try to tack on post-training.
Right.
What this research does is develop a scaling law, essentially a formula, for how to budget your compute for QAT during the main training run. It gives practical guidance to make QAT a planned, integral part of the process from the start, not just a fix at the end, optimizing the whole workflow.
So plan proficiency from day one.
Got it. And the last one, NVIDIA, again, with RLP, reinforcement learning pre-training. That sounds interesting.
It really is. The core idea here is using reinforcement learning techniques during the initial pre-training phase. Usually RLHF and stuff comes much later, after the model's basically built.
So what's the RL doing during pre-training? They're trying to teach the model to, quote, think before predicting. They use a reward signal based on information gain, essentially rewarding the model for steps that lead to a better final prediction on web text. Kind of like teaching it to show its work internally.
Huh. Teaching it to reason better at a fundamental level. Does it work?
Seems like it. They reported really significant performance boosts on tough benchmarks like math and science problems, gains of plus 19% up to plus 35% on smaller models, and crucially, these gains stack with the normal post-training alignment methods. So it's like injecting better reasoning ability right at the foundation.
Wow, okay. So let's try and wrap this whirlwind up. We've got this multi-front acceleration happening. OpenAI is pushing hard into social video, blurring lines around digital identity with Sora 2.
Right, while Anthropic and Zipu are locked in this intense fight over LLM coding skills, efficiency, and reliability, both proprietary and open source.
Then you've got this massive capital injection into periodic labs, betting that the future is automated, verifiable scientific discovery, moving beyond just text data.
And underpinning all of it are these fundamental advances in training efficiency. NVFP4 making giant models cheaper to build, QAT optimizing the process, and RLP trying to bake better reasoning right into the base models. The cost of running smarter, more capable AI seems to be structurally dropping.
Which brings us to that final, maybe slightly unsettling thought for you, our listener, to chew on. We mentioned sources flagging real anxiety in the computer science job market, right? Grads struggling.
Yeah, that undercurrent was definitely there.
So if AI is getting structurally cheaper to deploy, thanks to things like FP4, and simultaneously structurally better and more efficient at complex tasks like agentic coding or analysis, thanks to models like Claude 4.5 and techniques like RLP, what does that exponential improvement in cost performance actually mean for the future of, well, a lot of white-collar work?
How fast does that falling cost curve and rising capability curve start to reshape things? It's definitely something to keep a close eye on as this acceleration just keeps accelerating.